Welcome back, everybody. Thanks for joining. We're continuing our Chapter 13 notes on wildfires. And we've talked about some of the factors that cause fires and what fire actually is. Now we're going to be looking at least in this section, we're going to be looking at various different locations where we can expect wildfire risk to be highest, geographic locations. And some locations may be more obvious than others, and others might be a little more of a surprise. So deserts can experience wildfire. Now you might think, well, obviously deserts, because deserts are hot and deserts are dry. But one thing that deserts don't have as much of is the actual fuel. Since they are so dry, they're more devoid of vegetation and burnable fuel than other places. So they may be less prone to have, or you may think they're less prone to having wildfires, but they actually can. Rainforests can, believe it or not. I'll tell you one thing, with the human influence, one of the ways they've cleared rainforests, and you probably know that rainforests are really in a state of decline because of human interference. One way they use to clear rainforests is simply to burn them. They cut down trees as well, but burning is more effective, and so fire definitely can take place even in these very humid areas. Marsh and swamplands, definitely. Now, you may not think marsh and swamplands would be very good fuel because of all the humidity and all the dampness, but if they dry out, that decaying biomaterial makes very, very good fuel. So all these places right here can experience wildfires. Let's look at a few places in and around North America that the wildfire risk is the highest. So I'm going to be flipping back and forth to this map right here. The first place we're going to look at is Alaska. All right, Alaska and the western contiguous states in the United States. All right, so where is? Well, obviously Alaska is up here. Okay, and the western contiguous states. So even like up in the Rockies, right here. All right, places like that. Maybe not so much on the west coast because you've got a lot of humidity coming in, but especially right in here. These western states, contiguous means all connected together. Those states can experience wildfires. What else? Canadian Rockies. All right. Well, that's the place that I just kind of there for a minute, but the Canadian Rockies are right here. All right. So that whole area, a lot of green, a lot of vegetation. All right, and a lot of fuel. So all that is at risk of burning, especially as you move more towards the interior of the continent, because it tends to get a little bit drier right there and more prone to drought. Risk is higher. The belt that extends from the Yukon Territory southeast to Lake Superior and then to Labrador. All right, well, let me draw this, okay? First of all, where's the Yukon Territory? Well, Yukon Territory is an area of upper Canada. All right, this is the Yukon right here. Actually, I think it might be a little more west of that, but that extends down to Lake Superior. So Lake Superior is right here. That's the largest of the Great Lakes. And then over to Labrador. All right. Well, it's not just the name of a dog. In fact, as my understanding goes, Labrador Retrievers may have originated from that area, but Labrador is eastern Canada right here. This big belt of green, very high incidence, very high likelihood of wildfires. Okay, where else? Wildfires. Oh, that was the last one. Okay. Well, I'll show you another map that shows you more specific places in the United States. But it does shift from year to year, especially depending upon rainfall and how much moisture there is. The higher the moisture, the less likely you are to have wildfires because it ruins the fuel. So in the United States alone, these areas right here, so these are actual specific locations that wildfires took place. And so I had these western contiguous states marked out. You wouldn't have expected. Look at this, South Florida right there. Greatest wildfire hazard. A lot of wildfires in South Florida. You would think Florida, hot, yes, but humid and kind of damp possibly. Yeah, but if you have any kind of drought, this southern part of Florida right here with all these marshlands in the Everglades, if that stuff dries out at all, it makes for very, very efficient fuel. That biomaterial decaying makes for great fuel. And of course, all along the west here and the southwest, even up into the more wet states like Washington and Oregon. I'll tell you one thing, we think of Washington, we equate Washington State with being like Seattle and northern Oregon with Portland right there being wet and rainy. But as you move more east, I should say, Let me change my cursor here a minute. Here we go. As you move more east towards the eastern part of the states, they actually become very, very dry towards more than the interior of the continent. So a lot of these other places may seem more obvious to you. Of course, up in Alaska, even in Hawaii. Now, what might set these wildfires right here? Think of Hawaii, you think of volcanoes, right? And some wildfires actually have been set by volcanic lava flowing. But parts of these islands are actually kind of dry as well, so they do provide for some good fuel. But this is kind of interesting. Southern Florida having a lot of wildfires. All that because of that decaying biomaterial turning into very, very good fuel. Okay, so there were just a few areas, well, the main areas in North America that we can expect to get wildfires, or at least the risk is the highest. Now we're going to be looking at, in Section 4, kind of linkages between wildfires and other natural hazards, other kind of side effects and natural hazards that can be either caused by or result in wildfires. Obviously, the local environment is going to be affected. Vegetation. I actually kind of like this blue cursor a little bit better. Vegetation is burned, all right? Well, what does vegetation do for us? Vegetation takes in carbon dioxide. Plants, we tend to think of them breathing in carbon dioxide, but technically they kind of eat it, all right? And so with the vegetation gone, you've got less carbon dioxide consumption, and you've got more local carbon dioxide that can contribute to global warming. All right, smoke into the environment. All right, smoke is nothing more than aerosols. Remember, we said aerosols are solid and liquid particles. All right, so let me draw this in. I guess black right here makes the most sense. Smoke is just nothing more than airborne particles. It does contain a lot of gases, maybe some of the byproducts of burning, of combustion, but what you actually see is solids. Probably not liquids, but is solids. Unburned things, little bits of ash, all right, into the environment. That plays a part, especially in climate change, because we know that particulates or aerosols in the atmosphere, what they can do is they can have the effect of deflecting solar radiation away from the Earth and back to space. So that can actually have a cooling effect on the environment. That's kind of interesting. All right, the soil can become charred. All right, it becomes black. You know, if something burns, it tends to turn blackish or kind of carbonized, you might say. And one thing that can do is that can have effect on local heating as well, because dark surfaces are more prone to absorb energy. All right, and then give off a different, or I should say, absorb light, and then give off a different kind of energy in the form of infrared. So think of charred soil as being kind of like a blacktop. All right, it's always much hotter over a blacktop than it is over a lighter colored area. Landslides become more favorable as a result of wildfires. Why is that? Because, again, you're removing vegetation. What does vegetation do to prevent landslides? Vegetation holds the soil together because of the roots. All right, and so landslides are much more likely to take place as a result of wildfires. For the same reason, erosion and runoff are likely. Even if the whole hillside doesn't slide down, you do still have some of that charred soil or whatever soil is left remaining running off more easily because the vegetation is not there to keep it in place. And of course, wildlife is harmed. All right, and that has all kinds of other environmental implications as well. So the atmospheric environment, we kind of mentioned how wildfires affect that, but also the geologic environment as well. That is the composition of the soil, all right, and the materials that make up the ground right there. Both of those are affected a lot by wildfires. So one of the things that that wildfires does in particular is it can affect how the soil will take in moisture. All right, and that what that does is has an effect on how fire repellent it is in the future. Very hot fires, what they can do is they can not just bring about a chemical change in the fuel, but they can also have a change in the soil as well and create kind of like a hydrophobic layer. All right, let's take that word and break it apart a little bit right there. Hydro, you know, to mean water, and phobic literally means fearing. Like if you have a phobia, you're like acrophobia, you're afraid of heights. This means that it's a layer that I guess technically it means it's water fearing, but it really means that it's water repelling. All right, so that the moisture from rain or fog or dew, whatever, is less likely to be incorporated into the soil, and so that moisture can't get into the soil. So runoff, all right, and erosion and flood events are more likely to take place because the water can't go into the soil, and so it's going to be running off over top of it. Like I mentioned before, right, soil erosion and landslides, much more likely after wildfires because that vegetation being gone, you have less anchoring taking place, especially on steep slopes. All right, and so when it rains afterwards, and remember, in order for rain to take place, many cases you need some sort of particles in the air. Remember we talked about condensation nuclei, all right, particles like smoke or pollen or dust being in the air. What that does is that facilitates the formation of clouds. All right, and so after wildfires with all these particulates in the air, it is, in many cases, more likely for rain to take place. And so right after a wildfire, if it rains and you've got precipitation taking place, that exaggerates the effect of fires on landslides because you've got all that stuff running off. That stuff running off as a result of the wildfires. And so landslides can be a direct result of wildfires. Okay, so remember how I mentioned how that fires can create sort of this hydrophobic layer. All right, well, this right here being before the fire, you have obviously a living plant, all right, and you've got soil that is not wet but is wettable. That is, it can water can seep down through, and there's not much of a water repellent zone right here. All right, you've got on the very top surrounding the plants, you've got leaf litter, you've got all kinds of other biomaterial that is kind of providing moisture that can go into the soil. Once a fire takes place, we have an increased water repellent zone. All right, so that means that because of the chemical reaction that takes place and the heat, it changes this zone so that it's much thicker, so that the water is not able to get as effectively into the soil to be able to support the plants. So even if you do still have roots left behind, they may not be able to survive because those roots may still be in that water repellent zone and not able to return. In many cases, they do because of seeds and other kinds of organisms that rely on fires to reproduce. But sometimes, sometimes plant organisms cannot come back because of this water repellent zone that fire creates. Okay, so the atmospheric environment. I mentioned that briefly just a minute ago. Wildfires do actually create their own clouds. Now, you think, well, obviously they create smoke. Yes, but when I say clouds, I literally mean clouds like rain clouds. Why? Because of what we mentioned before. The clouds have a difficult time forming if there's not some sort of particulate matter in the air, that is solids or even liquids, that the water droplets can kind of condense onto. So they can make their own actual water, I want to say water vapor, but water droplet clouds because of the smoke, because of the smoke clouds that the fire puts into the air. So that smoke, that soot, unburned fuel material, other gases, they do help create actual clouds, but they also contribute to air pollution as well. So it makes it very difficult to breathe in. Many times people that are reported to have died in fires, you think, well, I guess the flames got to them. Well, maybe not immediately. Many people that die in fires are a result of breathing in these particulates, not necessarily dying because of the flames coming over them. So it's really smoke inhalation that gets a lot of people much before the flames actually reach them. All right, and big enough fires, you can have smoke and all these different pollutants going thousands of miles. Downwind means with the wind. All right, so I'll draw this right here. Here's your fire. Okay, on the ground, and so downwind is anywhere that the wind takes all these particles to. All right, so here's our particles right here. So they can be dropping hundreds or thousands of miles wherever the wind takes it from the fire. All right, we also have the formation of smog. All right, smog is kind of a slang term, and if you put it together, it's many people say it's kind of a combination of smoke and fog. All right, it may be water droplets, but also have a lot of these particulates, a lot of these aerosols in it. But it also contains a lot of gases. Carbon monoxide, you probably know to be a poisonous gas. When you When you breathe it in, what it does is it replaces oxygen in your lungs and doesn't enable your lungs to actually take in oxygen. So that's why people always say, make sure you don't ever run your car with your garage door shut, because cars put out, among other things, carbon monoxide. Volatile organic compounds. All right, volatile means likely to become gaseous. Okay, remember we said gaseous. Sorry, we said that. Take gasoline, for example. Gasoline itself doesn't actually burn. What burns is the vapors, the gases that gasoline turns into. All right, so we say gasoline is very volatile. So compounds that can become burnable are also released in this process and are found in smog. Also nitrogen oxides as well. All these things are found in smog. Even ozone, we think of ozone as being a good thing, but it's not good for humans to breathe in. So it's good up in the atmosphere where it blocks. What does it block? It blocks ultraviolet, right? And that's good because ultraviolet can give you cancer. But down at ground level, that's bad. We don't want to be breathing in ozone. All right, so a lot of what you see right here is actually smoke. That is just soot and all the other stuff that is created by wildfires. But some of what you see here is actually cloud that is formed because of those aerosols in the air, enabling water vapor to condense onto those solids and actually form droplets. So it's because of a fire, because of a wildfire, it's oftentimes very likely that you can have some rain not long after that as a result of the clouds that are formed. Okay, so those are some of the things that wildfires can cause. Linkages to other events. Now we're going to look at some of other events that can contribute to wildfires, and obviously climate change is a big thing. All right, the fact that the Earth is warming up, all right, increases the likelihood of wildfires. Why is that? Well, I mean, changes in temperature. All right, the warmer some area is, the more likely it is to experience wildfire. We also know that many forms of precipitation are a result of extra warmth. Why? Well, because extra warm air rises. Rising air condenses, and condensing air turns into precipitation. And so that and severe storms are all related to wildfires as being linked as natural disasters, natural hazards. All right. So as temperature goes up, humidity decreases. Remember we talked about relative humidity and warmer air. So let's draw like a warm, I'll draw a cold air mass here. All right, and a warm air mass right next to it. Warm air can hold more water vapor, all right? And so for a certain amount of water, a certain amount of mixing ratio in the air, the cold air mass is going to be more relatively humid than the warm air mass. So the warmer air is actually drier than a cold air mass would be. All right. So warmer air makes for drier conditions. As forests are replaced, as we cut down forests, and after all, forests take a long time to grow, and so as they're cut down, they certainly don't replace themselves right away. They're replaced with grasslands, and so more easily burnable fuel is created as climate change takes forests. Lightning strikes, all right? Lightning strikes are related very closely to cumulonimbus clouds and thunderstorms, all right? These increase ignitions, and these grasslands can be ignited. And also insect infestations as well, all right? As we have climate change and insects moving into areas where they weren't previously, what insects do is they kill trees. All right, they chew away at heartwood or certain things that keep trees alive. And so trees die and become a very effective source of burnable fuel. So all these things are related to climate change. Okay, so how do wildfires affect the biological environment? All right, living things, plants and animals. All right, well, some plants are susceptible to fire. Obviously, if you burn some plants, they're dead and they're no longer living organisms. All right, others are not. Some plants can withstand fire to some degree. Some plants even use fire to propagate or to reproduce. It's mentioned down here. If you saw the one video in class, well, whether you did or you didn't, it doesn't matter. But it's made mention of the jack pine, Jack pine. All right, and what this does is this has these kind of enclosed seeds that don't open up unless there's a certain amount of heat involved. All right, if there's a wildfire, the pine itself dies, but the seeds drop and open up, and then are able to take root and grow again. So this species has kind of adapted itself to surviving through wildfires. So if wildfires take place, it's almost like the trees are like, good, we're going to grow again. So that's kind of an interesting way that some plants respond to wildfires. Animals as well. The thing that animals can do, the plants can't do, is they can flee. All right. So even if they do flee, their habitat is changed. So they're now living somewhere else. But the habitats themselves are altered, so it may provide a habitat that is conducive to different kinds of animals coming in after the fire is gone. And it certainly determines how many types of animals can thrive there, because depending on the frequency of wildfires, it may not be able to support vertebrates that need a lot of, you might say that require a big food pyramid underneath it. All right? If there's not a whole lot of biological material to eat or consume, it may limit what kind of vertebrates can thrive right there. And of course, us. Humans. Does fire affect us? Absolutely. In many cases, fire can be good in a biological sense, but there's always the death and destruction part of it that tends to be inconvenient for us. All right, so how does fire affect us? Well, one of the things that you don't really think of, but it's the water quality is affected by wildfires. All right, you have a lot of soot left over and pollution, but also, as a result of wildfire, that increased erosion increases runoff, and that goes into the water table. All right, and so we can be dealing with the effects of wildfires long after the fire is put out. Some people are very susceptible to smoke and haze. All right, if you've got allergies, all right, you may get itchy eyes or respiratory problems or skin problems. Many cases, people with asthma are asked to move to places like, say, Arizona or New Mexico where it's drier. And that helps your asthma, but these places are also more likely to have wildfires, and so you may have breathing issues there for different reasons. All right, and of course, personal property, our stuff, our homes, our cars, our land. All right, that is torn down in a fire. All right, and as we move our civilization into these wild areas, it creates what's called a wildland-urban interface. Now, an interface is simply a line between two things. All right, so if you put your hand on the desk, all right, so there's your hand right there. You're putting on the desktop. Sorry, it's a pretty terrible hand. Actually, the hand isn't bad, but the fingers are pretty fat. And there's your desk right here. Right in between is the interface. All right, it's where two things meet. All right, so where you've got urban areas, like where we live, and wildlands, that produces a real problem because you have people right up against areas that are prime fuel to be burnt. All right, so all these are effects that affect plants and animals and also humans as well. I'm going to stop there for now. I'm going to pick up with the next video in section 5, I believe it is. But if you have any questions, please make sure you see me. In the meantime, thanks for watching, and I'll see you on the next one.